Welcome to task 4 of your work with matrices, an Okefenokee Food Web Learning task. In this task, you'll be working with food matrices or food webs and using matrices to represent the relationships between predators and prey. Hopefully you might learn something about the effect of, you could say, smaller animals or things that you might feel are not important in the food chain, like insects, maybe frogs, even mice. Because I swear, you never know that if you were being chased by a bear, that if you threw a fish at the bear might eat the fish and not you. But hopefully you don't get into that type of situation. But I do want you to kind of take a look at this food matrices, this food web, and kind of understand what's going on. Well, if I were to start here at fish, notice how there's an arrow that loops back towards the fish. That means that there are certain types of fish that eat fish. And then notice here that fish point to insects, fish eat insects, fish also eat crayfish, and fish eat tadpoles, frogs and tadpoles. Now, there are arrows pointing to fish, and those are coming from the bear. So that means that the bear eats fish, and the bear eats, the bear eats fish, and that raccoons also eat fish. But notice, raccoons don't just survive off fish. Raccoons also eat frogs and tadpoles. Raccoons also eat insects. And based on this food web, bears and raccoons are more or less your top level predators because nothing eats them. Now, I would argue, although this would be beyond the limits of this task, but I would argue that bears would eat a raccoon. I wouldn't say that a raccoon would try to eat a bear, but I would think, again, only outside of this task, I would think that bears eat raccoons. Now, one more thing before we go on. Insects are the only things that eat themselves other than fish. So crayfish are eaten and eat insects. Frogs and tadpoles are eaten and then eat crayfish. So that matrix is based off of what we refer to as a digraph, the food web, just another name for it. And notice here, looking at what we see, R and R stand for raccoon. So the 0 here says that raccoons do not eat raccoons. And the 1-1 means that raccoons eat frogs and tadpoles, and that raccoons also eat fish. Frogs and tadpoles has zeros going across because, as we can see in the diagram, frogs and tadpoles do not eat anything. They're more or less, what do you say? I can't remember the word for it, but they're produced in such great quantities that they feed other species and hopefully depend on smaller ones. Again, smaller ones that are not listed on this diagraph are just 3 animals. So fish, this last row for the 3x3 matrix, the fish don't eat raccoons, that's why it's a 0. The fish eat frogs and tadpoles, but the fish also eat themselves. So scrolling down a little bit further, number 1, they want you to create that matrix F, which I give you, and then you need to answer the question about what a column of zeros would indicate. I'll leave that up to you. You then need to answer the next few questions, 3 and 4. Direct food sources are more or less things like, for instance, raccoons have a direct food source to frogs and tadpoles. You can answer the rest of those questions. Now, when they talk about an intermediary, let's go back to our original matrix. The bears, I would say the bears eat insects, not directly, but through an intermediary. So when you create that first matrix and you square it, you actually represent or show or illustrate the relationships between a predator sorry about that. You illustrate the relationship between a predator, its prey, and the second level, I would say second level prey. But let me just make it simple. The bear eats the mice or mouse, but in actuality, the bear is eating the insect only because the mouse eats the insect. I hope that helps. So when I would say bears eat insects, they don't really directly. It's only when you square your matrix, as you'll see later in the task, but it's only when you square your matrix that you'll see that bears eat mice that eat the insects. You could also say that bears eat crayfish. Bears eat the mice. Well, actually, insects don't eat crayfish. Let's go to fish. All right, so bears eat fish. The fish eat frogs and tadpoles. The frogs and tadpoles eat crayfish. So just to tell you what that matrix would look like, let me get my pen ready. So your direct food source will be here. So this is one step. Squaring your matrix will give you the second tier or second level prey. But then when you cube it, and I don't know if you actually have to cube it in this task, but if you were to cube your matrix, you'll then find out what sources are through two animals. 1, 2. We refer to that as third level prey. Again, so you go to fish, that's direct. But if you were to go from bear to fish to frogs and tadpoles, that's through an intermediary or squaring the original matrix. If you were to go from the fish, frogs, and tadpoles to crayfish, that means that you cubed that matrix. And with that all said, considering how much you do with this task and how well you kind of accept it, you should be able to respond to some of the other questions. And you will certainly be able to answer how the food web is affected by pesticides when you remove, for instance, the insects, etc., by considering how the matrix looks. There was a question about what does a column of zeros represent? Well, that's important because you have to remember, and this is real life, like for real. If all the honeybees were to die off, that'll pose a problem for human beings. Honeybees do what? Hopefully you can answer that question. If you can't, then go to google.com and type in the importance of honeybees, or why honeybees are important. If you have any questions, please be sure to ask your online teacher.